Welcome to Chapter 3, everyone. We're going to be dealing with our first big unit on statistics and data. In this unit, we're going to be using the graphic display calculator quite a bit, and you need to have it with you charged up and ready to go at all times. Which is good. I mean, it's a good thing to be able to use the GDC calculator, but you also have quite a few skills to learn with it right now. So you'll notice also that this chapter is not huge. It only takes about maybe 2.5 weeks to get through. Really kind of short, but it is the first of 4 chapters in our book out of the 13 that it has that are devoted to data, statistics, and probability. So we need to really make sure that we get the ideas from this chapter very, very clear before we move on to the other stuff. Now, first thing we're going to be taking a look at is what we call univariate data. That means it's data that relates only to one variable. We're not accumulating multiple measurements or counts of things related to specific objects. So we're going to be measuring one thing. For example, we might be measuring the height of a number of children of a certain grade level, or we might count up how many cars, different households have, within our school community, et cetera, et cetera. Now, data comes in 2 main parts. We deal a lot with quantitative data, meaning data that's numerical, but it's not always numerical. Sometimes there's what we call qualitative data, and those are data points that the answer basically is a word. For example, if you were to go conduct a poll and find out what people's preference for flavor of ice cream was, that would be qualitative data. Or where they went on their last holiday off island. Well, those would all be qualitative. Quantitative ones are ones that we measure or count, and they are number-based. Okay. Let's see. The quantitative data, where we're going to, reside mostly in that domain, is it's divided into 2 camps. There's what we call discrete data, and there's continuous data. And basically it comes down to this. If discrete data is the things that we can count up, and they only come in whole number packages, going back to the example of the number of cars in the different households of CIS families, that would be an example. Continuous ones are ones we measure. For example, how long it takes a class in a PE to run 100 meters. You'd have a stopwatch out and you measure it. Or, how much milk you might pour into a glass. If you're attempting to make 100 milliliters, how close could you get? Those are things that we measure. So you got to keep the 2 quite separate, and they're going to the distinctions between those is going to become pretty profound later on in the course. Okay, here's an example. This is the number of cherries in 24 boxes. You go to the grocery store, you pick up 24 boxes of cherries, and you count up how many are in each one. Obviously, this is going to be what we call discrete numerical data. It's numerical because you're counting up, and it's discrete because it only comes in whole numbers. There's no things, they're not on purpose anyway, sell you half a cherry or a quarter of a cherry. So what happens is you go through the table and you take a look at all the different options that exist. Now, every box of cherries came either with 40, 41, 42, 43, 44, or 45. But looking in that little bubble up there at the top, you can see there's multiple cases of certain numbers of those. So what you can do is create this little table here, which we call a frequency table, because it doesn't just list how many cherries are in each of the boxes, but how many times. Now, this is certainly a nice summary table because you don't have to have all of the data written separately. It's implied when you see the frequency number beside it. So you just get your pencil and you'd fill them out. And I could see quickly that there were 7 boxes that had 43 cherries, and I don't have to go about there again and deal with that data ever again. Now, we can, let's say, here's another one, measuring the length of perhaps a cell phone call, and there's all the different times there. Now, rather than listing them all, sometimes what we'll do with continuous data like this, and this is continuous because we measure the duration of the telephone call, we create these little pockets of the domain, these little classifications here. How many were up to 5 minutes long, how many, 5 or up to 10, from 10 up to 15, etc. Notice the change of the inequality sign. So once you reach 10, you've cracked the threshold for the next classification up, and it goes up to but not including 15. That's because we have to have a very clear place to indicate where a 15 goes. It can't have this one 10 to 15 inclusively and this 15 to 20 inclusively, because then it's ambiguous as to where you would register the information about a call that was exactly 15 minutes long. So you got to make sure that distinction is there, and we're going to be using our TI to come up with information about that. Well, here's just another example. Men's jeans measured by waist size, 28, 30, 32, and so on, and there they all are. This is discrete data, absolutely. But if you actually measure the waist of 10 people, they wouldn't necessarily be there. Now, it's like a shoe size, or when we talk about how old people are, technically speaking, these are things that we measure, but we just classify them using a discrete number. Once you get past about 7 or 8 years old, no one says, "Oh, I'm 22 and 3/8 years old." Like that's something little kids do because they want to get older quicker. Okay, let's see what we got here. So discrete are things that are counted. Continuous are things that are measured, and you can usually tell from the context of a question which one's going to be which. Okay, let's try a real actual question here. Last football season, the Flames scored the following numbers of goals in each game. I can't even tell how many games. 2, 4, 6, 8, 10, something like that. Anyway, here we go. And there's a lot of zeros there. I see a lot of ones in there. What's the variable being considered here? That's the number of goals. Why is it discrete? Because they come in whole number packages. There's no such thing as half goals in football. Construct a frequency table. We can do that. And draw a column graph to display the data. And then we're going to figure out the modal score. Now, mode is one of those statistics words that you might remember from when you were younger. And it deals with what's the most common or the most frequently occurring one. So I'm going to do is I'm going to get my graphic display calculator. Now, I didn't make a video to embed on this. I'm just going to show you some screen captures, and I'm going to have my TI going in class. So if you have any questions about this, you got to let me know. So first thing we're going to do is we're going to make a new screen, and it's going to be a spreadsheet screen. And whenever you enter data into a spreadsheet on our calculator, and we're going to do it looks just like Sheets or Excel or whatever. You always have to name the column. So it was good enough on those laptop-based or desktop apps to leave it blank, and you can still process data. The TI does not allow you to do that. So you have to give it a name. Nothing fancy, not Shakespeare here, just goals I think would work because we're counting up the number of goals. And you can see that the 24 numbers in the chart below there have been stored. You do a quick check to make sure that your last number is entered on the 24th row, and you're probably good. Now what you do is you make a new screen, which is a calculator screen. You can go Control and then plus page on your GDC. You make a regular calculator screen, which is the first option. And here we go. Now in the menu button, remember the context sensitive menu, it looks at where you are and predicts, likely things that you want to do. And here from a blank calculator screen, statistics is one of them. And you go to stat calculations, and you can then access the first one, which is called one variable statistics, and it'll ask you which one, and of course all the data is stored under the column denoted with the word goals. Okay, now here's a couple things we're going to have to look at and understand. When you see the variable x here with a bar on top, we actually call it x bar, that's what we say, and 1.58. And what that means is that's the mean, or the arithmetic average. This is when we add up all of the data points and divide by how many there were. And 1.58. Now, obviously with a mean, the mean is a gauge, an average. It doesn't necessarily denote a score that was even possible to be computed. Obviously, no one is ever going to score 1.58333 goals, but it's just a gauge to give you an idea of approximately what happens on each go. You can see over here there's more things. N is 24. It's just reminding us that there's 24. There's a lot of other things in this chart here I'm not going to bother talking about. Not yet, anyway. If you make a new screen now, we go Control plus page. We're going to go to number 5, which is the data and statistics page, and all of your data will appear. And again, I'll show you how you can arrange that in class. I didn't make an embedded video for this, but it now allows us to work out the modal score. From this chart, I think it's really obvious which score total happened the most often, because it would simply be the column that's got the most number of dots in it. And we're not required to know how many, just which one is the highest. And so the score of one goal was the most frequently occurring event for this soccer team. Here we go. How else do we get? You get the kindergarten class. Look at the number of vehicles that passed by the school in the early morning. And they did this 30 consecutive weekdays. So we got 6 weeks of school, and there's all the numbers there. Now, what you could do in this case is create your own classification system. Now, this is discrete data, but you're still only looking at class intervals. And so there's usually some guidance given as to how to create these tables. Now, they've decided to go from 0 to 9. That's like 10 different numbers, right? 0 up to 9. And then all the teens, the 20s, 30s, etc. And as you encounter a number here like 27, you just put a tally down, tick it on that list there, and then afterward you can create this frequency column, which is basically converting all these tick or dash marks into a number. Okay, so how do we process this? Again, we're going to go, you can see that here, this is a different kind of chart, and I'm going to show you the important distinction here in mathematics. You probably just looked at this a million times in your life, but overlooked this one key idea. If you're talking about discrete data, the bars on a frequency chart or some sort of table like that have to have gaps between them, and that is indicative of the fact that the data is not continuous. If the data was continuous, something that we measured, one class interval would feed directly into the next, and therefore there shouldn't be a gap between them. It's sort of indicative of the free flow and the continuity along the domain. So you've got gaps there. Let's take a look here. Here we're going to be measuring lobsters. Again, we're going to create a frequency table, and we're going to come up with some sort of class interval length, and then we're going to, dump each of those different, what are they, 10, 20 scores into a table. So here's what I've done. I've chosen to go from 3 up to 4, and then from 4 up to 5, 5 up to 6, and then I've gone through the 20 scores and I've registered, and I've got those frequencies. If I wanted to put them in a chart, it would look like that, and notice that those gaps between the bars have disappeared. That's it. That's ready for 3A, and there's only a couple of questions here to do. Basically, what we're trying to get at this stage with you is to clearly understand the distinction between discrete and continuous, and then also how frequency tables work and how to get some basic information from your GDC. Nothing much, but more is coming up very soon. Okay, let's get to work.